Hello, my dear students. Welcome to question number 28 of the competency series for ICSE class 10. We have done 27 another questions before this. Make sure to watch them as well because each and every question that we are doing is extremely important, competency focused, and very conceptual. So the link of all the questions is given in the description box of this video. The link will take you to the playlist where all the competency questions are arranged in proper sequence. So make sure to watch them. Let us continue with this question 28. Okay, so this is from the topic work, energy, and power. Two students are conducting experiments with identical 100-gram mass simple pendulums, each raising the bob 5 meter above the mean position. So there are two different students. Each of the students has 100-gram mass simple pendulum. And what each of them is doing, each of them is raising the bob 5 meter above the mean position. If I draw the simple pendulum, it would be something like this. When it is at the mean position here, this, and when it is at the extreme position, so what is being said when the bob is at the extreme position, this bob, the mass is given, okay, 100 gram. Now when it is at the extreme position, so it is at how much height from the mean position? The height, the maximum height is given 5 meter. It's given in the question, 5 meter above the mean position. So each of them is raising it. All right, boy, the student 1 as well as the student 2 is doing the experiment separately. Each of them has 100-gram mass and each of them is doing the same experiment, raising the bob high, 5 meter above the mean position. That means this is the extreme position. The graph depicting the relationship between the distance from the mean position and the velocities is presented in the diagram. So let us see what the graph is telling. Here the student 1, for the student 1 the graph has been plotted. Here you can see on the y-axis we have velocity given, velocity of the bob. At extreme position the velocity is 0 and at mean position the velocity is 10 meter per second. It is given in the question. And at another extreme position again the velocity is 0. So we know that when the bob is oscillating, when the simple pendulum is oscillating at the extreme position, the velocity becomes 0. We already know that. When the bob comes to the extreme position, it stops for a while and then again it starts coming to the mean position. So at extreme position, at either of the extreme position, even at another extreme position also, the velocity becomes 0. So no doubt that at extreme position the velocity should be 0, so which is very obvious. Now at mean position, you know that the kinetic energy is maximum, and that means the velocity should be maximum, and the velocity is given for student 1. The bob has 10 meter per second of velocity at the mean position, it is written. And for the student 2, this very same bob, 100-gram bob, has a velocity of 8 meter per second at the mean position. So there is some decrease in the speed. Anyway, let us now study what the question is asking us. Demonstrate using mathematical calculations that the path followed by student 1 is devoid of friction. Devoid of friction means there is no friction in the path of the where the student 1 is doing the experiment. It means, what do we actually have to show? Is devoid of friction means what? Means there is no loss of energy taking place. That means we have to actually prove that the potential energy at extreme position, we have to prove this very thing. The potential energy at the extreme position is same as the kinetic energy at mean position. If there is no difference between them, whatever potential energy is at the extreme position is exactly same with the kinetic energy at the mean position, it means there is no loss of energy. The entire potential energy at the extreme position converted to kinetic energy when it reached the mean position. So if we are able to prove this, we will be able to say that the path is devoid of friction. There is no friction at all. Because only if friction is present, there would be some loss of energy. So let's prove this. So you see, let us calculate the potential energy at the extreme position first. So we are calculating the potential energy of the bob at extreme position. How do we calculate the potential energy? What's the formula? The formula is mgh. M is the mass of the pendulum, which is given. You can see it is given in the question, 100 gram, which is 0.1 kg. 0.1 kg. Let us not write kg. We will write the unit later. G is 10 meter per second square. It is told in the question that we have to use G as 10 meter per second square. However, it is not printed here, but it has been told in the original question, so I know it. H is the height above which the bob is raised. So we know that the height is 5 meter above the extreme position, above the mean position, isn't it? So that will give you, that is giving you 5 joules. So this is the potential energy at the extreme position. Now let us calculate what is the kinetic energy of the bob at mean position. And for kinetic energy, we have the formula half mv square. We can use this formula because we know the mass, we know the velocity of the bob at the mean position. For student 1, okay, whatever we are doing right now for the part A, we are actually doing for student 1, isn't it? So the bob's weight or mass is 0.1 kg. Velocity, if you see for student 1, the velocity of the bob at mean position is 10 meter per second. It's given in the question. So it is 10 into 10, right? So 2 5s are 10. And we again see this is also coming to be 5 joules. Wonderful. So we are able to see that since the potential energy at extreme position is equal to kinetic energy at mean position, therefore the path, what is the statement in the question? The path followed by student 1 is devoid of friction. So we are able to prove it. The path followed by student 1 is devoid of friction. Alright, now let's see what the question is asking in part B. Does the situation involving student 2, this particular graph, exhibit a breach of the law of conservation of energy? Breach means, does it violate the law of conservation of energy? Does it violate the second student's data? So let us calculate the part B here. So potential energy at extreme position, that is same. There is no change here. That is 5 joules that we have already calculated. mgh is 5 joule. Now what about the kinetic energy at mean position? At mean position. So that is, let us calculate, half into 0.1 into the speed is 8. So 8 into 8. So that is 8 multiplied with 4 multiplied with 0.1, that is 3.2. So there is 1.8 joules difference, isn't it? If you subtract 5 joules and 3.2 joules, there is a difference of 1.8 joules. Those 1.8 joules, where did it go? Where did the 1.8 joules go? The entire potential energy did not convert into kinetic energy. That means there is some loss of energy, which is obvious because there is friction in real world. So the difference of energies, which is equal to 1.8 joules, is converted to heat energy or other forms of energy. Alright, there is friction. So with the friction, when the bob is oscillating with the air and getting in touch with the air molecules, so there is friction. So heat is produced. So the difference, a 1.8 joules, is getting converted to heat energy and maybe sound energy as well. other forms of energy. So does it exhibit a breach of law of conservation of energy? No, it does not violate. This is a real life situation. When would we say that there is a violation of law of conservation of energy? When we would see a situation like here, we suppose we get kinetic energy at mean position is 6 joule or 7 joule, which is more than 5 joules. If suppose we were getting something like that, then that is completely a violation of the conservation of energy, because potential energy at extreme position is 5 joule, and if the kinetic energy at mean position becomes more than 5 joules, then that is impossible. How would then extra energy come from? So if that had been the case, we would have said that, yeah, that would have been a breach of law of conservation of energy. But here it's nothing like that. The kinetic energy is less than the potential energy at the extreme position. So yes, this is obvious, and this happens. This is actually a scenario which is very true in our real life situation. So no, the situation involving student 2 does not exhibit the law of conservation of energy. Law of conservation of energy. So with this, we end this question. I hope you enjoyed this question. You understood the concept that was involved in solving this question, isn't it? So make sure to watch all the previous questions as well. I already told that the link of the playlist is given in the description box of this video. Keep tuned to the channel. Do not miss out any of the competency based questions. Thank you. Take care. See you in the next video.